Hello class. In this video we'll be covering the first half of Chapter 5 in the Programming Logic and Design textbook. We'll be taking a look at the advantages of looping, how we can use a loop control variable to control our loop and how many iterations it performs, what nested loops are and how they can be used to solve more complex problems. And we're going to look at a few common loop mistakes. The remaining bullet points will be covered in a future video. So basically the idea of programming loops are that they make programming more efficient, more worthwhile, because we're able to identify a set of instructions that we want to execute multiple times. It allows us to write programs more quickly, so it's more efficient for programmers and less error-prone because we can write and test just one time and then allow that loop to run multiple times. It also has shorter compile time because our code actually gets a little bit shorter because we can identify a set of instructions that we want to iterate, in other words, execute through multiple times. So a loop is a structure that repeats a set of actions while some loop condition continues to be true. And we saw this structure in earlier chapters. Here is a very general form for a loop. The diamond shape represents a decision or a test. We also called this a Boolean expression that evaluates to either true or false. For example, while x is greater than 3, x greater than 3 could be a condition that is represented in this diamond shape. The rectangle shape here that we see represents the loop body, or what we're doing inside the loop. So if x is greater than 3, what is it we want to do? We have this rectangle here as in a general way, but understand that there could be multiple steps that we perform inside of the loop body. It is also important to understand that this flow line loops back around to connect to the test, to repeat the test after each iteration of the loop. The textbook shares with us that it's not uncommon to see the loop in the context of a modularized program. Remember, a modularized program is one in which we've broken up the program into specific named pieces, and we call those pieces when we need them. Now, this particular slide doesn't show all the details, so housekeeping, although we see it being invoked or called here, we don't see the definition of housekeeping. So it's just showing us at a very high level view that it is not uncommon for a program to get started by declaring variables and then do some actions in housekeeping that set us up for the beginning of our program. An example in a realistic program might be opening a connection to a database. Programs often work in conjunction with data. So we might be opening a connection to a database so that we could read data from a table called patients or customers, for example. Then we might begin a loop. And again, this is very generic. It says while not end of file. So that's meaning, while there's more records to process or more work to be done. In future programs and in real compiled programs, we'll see something more concrete here, a test for a value that maybe we read in from the user or some other value. But the test, if it evaluates to true or yes, for example, then we go on to execute the detail loop. This is the body of the loop. Detail loop contains the steps that we want to perform while that test is true. Eventually, we're going to loop back around and the test will evaluate to false, at which point, our textbook author is showing us we might want to do some wrap-up activities, and those are represented in the end of job. For example, going back to our database connection, this could be where we close our connection to the database. So a loop continues to iterate as long as the loop condition remains true. And we represent loops in pseudocode, and we'll see shortly in future weeks in our compiled programming statements with a while loop. It's very important to understand that every time we have a loop, we should have three things. 1, 2, 3 right here. Loop control variable needs to be initialized before entering loop. Let's back up a second. What's a loop control variable? A loop control variable is exactly what it sounds like. It is there to control how many times a loop iterates. In other words, how many times it executes. So we're going to find that is important that loop control variable will be set to a specific value before the loop starts so that we can keep track of how many times the loop iterates. We're also going to test the loop control variable. This is a test such as while x is greater than 3, just for example. And then the last requirement is the body of the loop must alter that loop control variable. Somewhere in the loop body, that loop control variable must be executed, or I'm sorry, updated in order to avoid our loop running forever. That's called an infinite loop and something that we want to avoid. This bottom piece is referring to the fact that there's two basic types of loops, counter-controlled loops and Sentinel-controlled loops. The first tends to be a little easier for students to grasp, so let's talk about that one first, the counter-controlled loop. It is used to create a loop that runs a definite number of times. For example, I can create a loop that loops through and gets 10 ages from the user. That would be a counter-controlled loop because it runs exactly 10 times. The second type of loop that is also called an indefinite loop or a Sentinel-controlled loop, it works a little bit differently. It works in a manner where we're checking a loop control variable, but instead of counting the number of times, maybe we check, for example, the user's input. Loop while the age provided by the user is not equal to 0 would be an example. So we don't know how many times this loop is going to execute. It would depend on some outside force, such as the user's input. So let's look at the first one. Definite loop, also called counter-controlled loop, iterates a predetermined number of times. And we're going to use a loop control variable, often called a counter, which is a numeric variable. And we're going to either increment it or decrement it, in other words, add or subtract, usually the value of 1 to that counter, to keep track of how many times the loop has executed. The author shares with us that a counter usually starts with 0, although I want to add that oftentimes programmers start a counter at the value of 1. So a lot of this is programming preference. As we'll see, you can construct a loop to execute a given number of times multiple different ways and it still be correct. The key is, going back to my example of ages, collecting 10 ages from the user, the key is making sure that that loop iterates the number of times that we want to. So in that example, 10 times. So here's a very straightforward example. I'm actually going to skip forward for a second to this slide. If you look on the left, this shows the output of that particular, oops, I apologize, nope, got a little ahead of myself there. That is the next slide. I apologize. This particular program is going to output the word hello exactly 4 times to the user. So it is not going to ask the user for input. It is just going to get going, print hello, print hello, print hello. It's going to go through that 4 times, and then it's going to print the words goodbye. That's all. So let's take a look at the program. We needed a way to keep track of how many times the loop iterated, how many times it ran. So we chose to create a numeric variable called count, and I'm going to pause there and say they chose to call it count. It could have been called anything. It's just programmer convention that we choose a name like count, counter. A lot of programmers like to use the variable I, it stands for iterator, J or K. You'll often see those in programming examples, so it is not required that the name be called count or counter. Okay, that's important to realize. But they created this variable of type number and started it at 0. So here we're initializing the loop control variable to start at 0. That is the first requirement of every loop. The second requirement is that we check to see is the count less than 4. So this test ensures that we haven't already met the maximum number of times to iterate through this loop. So since we wanted to output hello 4 times and we started it at 0, we ensured that we kept it less than 4, because first time through count will be 0, then 1, then 2, then 3. That would be a total of 4 times. So this test will keep us in line for executing the following body 4 times. So the first time through count is 0. So we get to this test. 0 is less than 4. Yes, it is. So we output hello. The other critical piece of all loops is that we increment count by adding 1 to its value. This last piece is critical. If we would forget this step, we would end up with an infinite loop that never ends. So here, we set count equal to count plus 1. Well, count is currently 0 the first time through, so 0 plus 1 is 1. So this essentially updates count to 1. We loop back around. Test 1 is less than 4. Yes, it is. So we go in again. We output hello. So this pattern continues. The last time through, when count is 3, we output hello. We update count to count plus 1 one last time. Count becomes 4. And when we loop back around, the test for 4 less than 4 fails, meaning that our loop will now terminate. And finally, we have one final output that indicates goodbye. Over here, you can see the corresponding pseudocode. Notice we use a while to represent the loop test, while counts less than 4. Inside, we have the statements that are in the loop. We call this the body of the loop, or the loop block. And then end while is used to close off and to show where the end of the definition of that loop is. So when we execute through here and we hit these steps end while, we'll jump back up to while to make the next comparison with count and 4. So that was the first type of loop. The second type of loop is called a Sentinel controlled loop, or an indefinite loop. In this type of loop, we're performing the loop or iterating through the loop a different number of times each time the program executes. It's not a definite amount of times. So this is what I had meant to show you. This little screenshot on the left says, do you want to continue, yes or no? And then the Y over here to the right is indicating the user has typed yes. So as long as they typed yes, you'll notice the program outputs hello. Once the user finally types no, the program outputs goodbye. So in this case, we output hello 3 times, but as you can imagine, we could run the same program again and say hello 100 times, because the user never typed N until we reached that 100 output of the word hello. So depending upon the user's input, we're going to iterate through that loop a variable number of times. So let's see how this is done. So this program starts out by declaring a string called should continue. Should continue is going to store the value of y or n based on what the user inputs. So the first thing it does is it outputs, do you want to continue y or n? And then it reads in that value to should continue. So it is important to realize that even though we're not using a variable called count, this particular step to input should continue is initializing the loop control variable should continue. Should continue, since it controls the loop and whether or not to enter the body of the loop, is the loop control variable. So in this sense, we initialize that variable by getting the value from the user. So we still have that step to initialize the loop control variable, as well as the test here. While should continue is equal to y, we go in and output hello. And again, remember the third requirement of every loop is that the loop control variable is altered. So since should continue is the loop control variable, the last few steps we see in the loop body is to get the next value for should continue from the user. That ensures that when we loop back around to the test should continue equal y, we have a new value from the user. So in both the definite loops, the counter-controlled, and the indefinite loops that we're looking at here, we still have all three requirements. The loop control variables initialized, tested, and altered. And this is just reiterating those points, that all three of those points are required for every loop. We need to provide a starting value for the loop control variable, we need to test it, and inside the loop body, we need to alter that loop control variable. So this is just kind of rehashing a familiar program, the payroll report program that we saw earlier. This particular program, if you recall, printed a report, said payroll report at the top, and it had some column headings, but it went through and asked the user for an employee's name. Once it got the employee's name, it also asked for their gross pay, and based on gross pay, it did a few calculations. It calculated the deductions and the net, and then it created an output line that represented a row in the report for that employee's name, gross pay, deductions, and net. So again, we've seen this before. We actually saw loops in earlier chapters. Now we're just looking at it a little more carefully. So for this particular program, you can see that we are dealing with a Sentinel controlled loop, also called an indefinite loop. And we know that because we didn't execute to get exactly 10 employees' names. We let the user indicate when they were done entering employees' names by typing XXX. In that case, XXX is what you call a Sentinel value and is what is used in the loop comparison. So if you look here, note start is our main flow. We start out by creating some variables. Quit is equal to XXX. We're going to use that a little bit later. It's a constant we're going to compare to the loop control variable. And then it executes housekeeping. Housekeeping prints some headers, but the first thing it does is get the first name from the user. It says, enter the employee's first name. We get that value, and then we compare it to XXX. So the interesting thing about this is even though before this loop we're executing housekeeping, by inputting the first name in housekeeping, we are initializing that loop control variable. So it's important to realize those three requirements of every loop might happen in a different module other than main, but they are still all happening. We get the first name that initializes the loop control variable name. Here is the test, name not equal to quit. And detail loop then, in addition to printing the values for the report, we'll get the next name. So you can see the last step in this detail loop is to get the next name. That updates the loop control variable name so that when we return back and we loop back around to this test, we have a new name to compare with quit. So if the name is XXX, we now know, okay, it is no longer not equal to XXX, so we will exit the loop. There is also this concept of nested loops. Loops can be nested within other loops, and we do this, I always say, when we have the many within many scenario. So to give you an example, in our class, each student takes multiple tests. So I could say I want the exam average for each student. I want to know what their average was across the 3 tests that they took. So I could build a loop that loops through and gets the 3 exam scores for that student and calculates the average. But every class has multiple students. So if I wanted to, for multiple students, calculate the exam average over 3 exams, I could use nested loops to do that. My outer loop would loop through all of the students, and my inner loop would loop through and get the 3 exam scores for each student. Here's another example of using nested loops. In this particular example, we want to create something that you see on the left-hand side here. On the left, we created what we're calling quiz answer sheets. Imagine we wanted to print out these little quizzes and hand out to students so that they could write their answers on question line numbers 1, 2, and 3. But notice that each quiz has exactly 5 parts, and each part has exactly 3 questions. So because we have exactly 3 questions, we could build a counter-controlled loop that loops through and prints exactly 3 questions. However, that loop would be nested inside a loop that creates output for exactly 5 parts. So you can see the many within many happening in this example. Furthermore, each of these 5 parts, which would be another counter-controlled loop, is nested inside multiple quizzes. Now, in this case, I'm going to tell you that the program will loop through and create these little quiz answer sheets. And we're going to ask the user to provide a quiz name. As long as the quiz name's not ZZZ, we'll keep making quizzes for them. So we have 3 nested loops, the outermost of which collects the quiz name. So over here on the right, we don't see the complete program. We see the main line logic, as well as housekeeping and end of job. Detail loops on the next slide. But you can see that we get a quiz name in housekeeping and we compare it to ZZZ. As long as the quiz name's not ZZZ, we go on to the detail loop. And detail loop presumably does some things and then gets the next quiz name. So we have all 3 requirements. We have read in the first quiz name, we compare it, and we're going to update it in detail loop. But this outermost loop is a Sentinel controlled loop because we don't know. The user could theoretically type in ZZZ the first time through and not print any quizzes, or they could create 100 quizzes. As you're going to see in the next slide, detail loop handles the printing of each quiz. As we said, each quiz has 5 parts, so we're going to see an outer loop that loops through 5 times. But for each part, we're going to print 3 questions. So again, we're going to see a nested loop that loops through and prints 3 questions. So here's the detail loop. We start out by printing the quiz name. That's going to be for the top of the form. And then we want to print 5 parts for that quiz. So notice that we have a separate variable, it was actually declared over here, part number, and we initialize it to 1. So I'm going to stop right there and emphasize that when you're using nested loops, each loop has its own loop control variable. So the outermost loop had a loop control variable called quiz name. This loop that controls the parts has a loop control variable called part counter. It sets it to 1, and as long as it's less than or equal to parts, which was 5, we're going to keep looping. So everything inside of this loop is responsible for printing a part. It outputs a part label. It starts a question counter at 1, and then we have this inner loop that as long as a question counter that starts as 1 is less than or equal to 3, questions is equal to 3, we're going to loop through and print out the value of the counter, which incidentally is going to be 1, 2, or 3. That's giving us that numeric value 1, 2, and 3. And it's going to print out a line. That's giving us that nice line that the user would actually write their answer on. If you look back, let's look back here at a constant called line. This is printing that line piece that we see that the user would write their answer on the answer sheet. The user of our quiz, rather, that we're printing this for. And then it increments question counter. So we see now we have 3 levels of nesting. 2 of the inner loops are actually defined inside of detail loop, but altogether we have 3 different levels of loops. The outermost is a Sentinel controlled loop, as we saw in main. In detail loop, we have two nested counter controlled loops, one that uses part counter to control it, one that uses question counter to control it. And here you can see the corresponding pseudocode. Up here in main, we see the while loop corresponding to the outermost Sentinel controlled loop. Down here in detail loops definition, we can see the while loop corresponding for parts, as well as the steps inside of it for printing a part. It is critical to understand that to print a part, we need to print 3 questions. So here we begin the loop for the questions. We start question counter at 1. While that's less than the total number of questions we want, we loop through and print the questions. So it's nothing that we haven't learned already. It's really just putting all those pieces together. And when you review this, you want to review this carefully for the placement of the end whiles for each corresponding nested loop and how all the pieces fit together. Couple nested loop facts. Nested loops never overlap. An inner loop is always completely contained within an outer loop. So if you look back here, this inner loop for questions here is nested inside of, completely nested inside of this loop for parts. An inner loop goes through all of its iterations each time its outer loop goes through just one. So when we're printing part 1 on the first quiz, we're going to loop through the innermost loop that prints the questions 3 times for each part that we print. So there are some common loop mistakes. The big picture here, folks, is don't forget to initialize the loop control variable, test it, and alter it. And that's what these various slides are referring to. Another mistake that you can make is using the wrong comparison when testing a loop control variable. Programmers must use the correct comparison. And if you use the wrong comparison, what's going to happen isn't that your program won't compile. Most likely your program will compile and execute. However, it's a little dangerous because you've probably created what's called a logic error, meaning your program runs, but it doesn't produce the correct output. So they give some examples here. We might overbook a flight. We might, overcharge an insurance customer. So we have to be careful about our loop tests. Here they show us in the previous example that went through and printed hello, we've modified it a bit. We ask the user for a name, and as long as the name is not equal to ZZZ, we output hello and then the individual's name. So that's a Sentinel controlled loop. That's fine to do. We've initialized the loop control variable. Here we test it and we get the next name as the last part of the loop. But the problem with this particular program is instead of testing while name was not equal to quit, we accidentally said greater than quit. Well, when you use a greater than sign with a string variable, it's going to do an alphabetical comparison. Chances are ZZZ, because it occurs later in the alphabet, is always going to be bigger than name. So this loop will run infinitely. So that's not something we want. So just make sure you use the correct comparisons. This next example is interesting. It uses the correct comparison. They're making a very subtle point in the text. Sometimes you want to consider efficiency with your loop. This particular program might relate to those of you that might be working in retail right now. So some stores print a little price tag on what they call a sticker that they place on an item. We're going to make some assumptions in the program you're going to see next. The assumption is that this program prints stickers for items. It prints 100 stickers for each item. The other assumption we're making is that we are going to keep printing stickers for items and for multiple items, as long as the price the user provides is not equal to 0. When they type 0, they are indicating they are done and we will end our program. The other assumption we're making is we want to discount every price by 30% before we print the sticker. So let's take a look. So this program has a couple variables up here, a price, we're going to get that value from the user, a discount of 30%, a new price, we're going to use that to store the discounted price, a sticker count, that's going to be our loop control variable for our inner loop that loops through and prints 100 stickers, and then a constant called stickers that's set to 100. We'll use that for our comparison later. So the program starts, housekeeping gets the first price. It says, please enter original price of item or 0 to quit. We come back here as long as they have not typed 0. So again, this is a Sentinel controlled loop. Theoretically, they could type 0 the first time through. But let's say they type a value that's not equal to 0. What happens? We go into the detail loop. The detail loop says, okay, I'm going to print 100 stickers. So I'll start a sticker count at 0. And as long as it's less than 100, I'll go through and calculate the discounted price, and then I'll print the sticker. That's our output statement here, prints the new price. And then I'll increment sticker count so I don't end up in an infinite loop, and I indicate, okay, I printed that sticker, now sticker count is 1. And it keeps going through this pattern. So this program works. It works very well, and it is correct. But one thing the author is identifying here is that we are actually recalculating the new price for an item 100 times when we don't need to do so. We're printing 100 stickers of the same value, so why are we recalculating that new price 100 times? Remember, anything that's in this loop body is going to iterate multiple times. A better way to do this would be to restructure the detail loop. Before we start the loop, let's calculate the new price, and then go in and print our 100 stickers based on that new price. This shaves off work for the program, making it more efficient. Here we've moved in the pseudocode that step for new price to occur before the loop begins, because we know the new price is going to be the same for every 100 of those stickers. That's where we're going to end up, folks, for this video. Thank you. I plan to create a second video for the second part of the chapter.